what's up everybody? My name is Victor. I'm a software engineer and a private tutor for aspiring developers who want to feel confident on coding interviews. So if you're interested in preparing for coding interviews, please subscribe to this channel. Alright, and today we're gonna solve this problem, which is called combination sum. And we're given a set of candidate numbers. A set means that there is no duplicates here, and a target number. And we need to find all unique combinations in these candidates where the candidate number sums to target. The same repeated number may be chosen from candidates unlimited number of times. And also we have two nodes here. All numbers including this target will be positive integers. And the solution set should not contain duplicate combinations. Alright, to understand this problem, it's better to open a sketchpad and try to represent it as a tree. So let's try to draw a little bit, and I have really poor drawing skills, so please excuse me. And yeah, okay, let's get started. So imagine that we take the first candidate from these numbers and we try to put it in a path which should lead us to an answer, to one of these answers, right, which we need to get. So if we take 2 and we start from the candidate 7 and current path is 2, we get 5 as a second node in this tree. So a transition between two nodes means that we tried to find the next target. So we just took 2, right, in this path, and it means that we need to explore our candidates once again and try to find one of them, one of these numbers, which we also need to put into our path. But now we need to find this target 5, right, since we already reduced the size of this problem. So for this target 5, we just do the same exercise. We start from the beginning, since it says that the same repeated number may be chosen unlimited number of times, right? And it means that we just tried 2, but we need to do this once again. So we try 2 once again, put it in our current path, and the second node in this tree, which is connected with this previous one, should be 3, right? Let's do this once again. This second node is 1, and we add 2 once again. Then we add 2 once again, and the second node is -1. So when we get this negative number, it means that this is a dead branch. It means that there is no way that we will continue, at this point, and we will get the answer. There is no way, since it says that all the numbers are positive, and it means that if we just got negative target, that's the dead branch. So let's just prune it. Let's remove this last number from the path and try to explore another one. And another one is 3, right? Another candidate. So if we take 3, for instance, we just get -2, and the same for all these nodes, -5 and -6, right? And all these numbers turn out to be dead branches. So we get back here and try to explore another one. And another one is 3, so we get 0 as our as our next target, right? We put 3 here in our current path, and if we get 0, it means that we already found the answer, right? One of the answers. So we take this path and put it to the result set. So we can explore this with the same manner for 6 and 7. We will get here some negative numbers, and using the same exercise for all possible paths, we will explore all answers, and each time when we get 0, we just put the current path to the result set. So that's the idea. Let's try to come up with a more formal algorithm. So imagine that we have a function. That function takes a current node and try to explore using these candidates all other nodes. So basically, let's think about our base case. If we have target which is equal to 0, it means that put the current path to the answers, to the result set. So if target is greater than 0, and it could be even less than 0, but we will talk a little bit later, or like literally in this step. We don't want to have this situation where we actually call this function with the target less than 0. So for each candidate, we need to get the next target, reducing it, right? Reducing the current one. Then we have the next target. We need to call this function once again to explore other paths, but here is one caveat. We need to do this only if the next target is greater than 0. So if the next target is greater than 0, call this function, call it recursively with the next target. And basically that's it. So there are a couple of optimizations here. So for instance, you might notice that in this case, in this particular case, we have these candidates sorted, and it means that at some point, if we get this negative target, it doesn't make sense to check other targets, right, for all the next candidates, since they are all going to be less than 0, right, since this array is already sorted. And it means that we can save like a couple of operations, and it means that there is no requirement here that these candidates is already sorted. So as a first step, we might sort the candidates, and here if the next target is less than 0, just break the search for the next candidates. So it doesn't make sense to proceed. Yeah, so basically that's it, that's the idea. So I will post the link to the actual code which I host on GitHub, for this particular solution in the comments, so please check them. And as usual, if you have any questions, just ask them in the comments below. I'll be happy to answer those. Thanks for watching and keep rocking.